Hello Nexters, welcome to another Whiteboard Wednesday on 1 p.m. CET, of course, whatever time it is where you are. Today we're doing remote production and will it change everything? Well, of course it will, but let's get on with it as quickly as we can. So, working from home basically pushed us into another realm, particularly around remote production, and it kind of revealed a technical debt. I talked about this a little with the streamers last week, but it revealed a technical debt that the broadcast community really had to systems that were out there that streamers were using. So things like OBS and vMix, etc. And also, Zoom and Teams, things that weren't really, of a quality for on air, were starting to be used more and more and more in the pandemic. And bringing all that together created how we actually bridged that technical debt gap that we had to that technology. So. When it comes to remote production, mostly we're talking about three things. We're talking about controlling things remotely. So how do you actually control something from somewhere else? Latency, our old friend latency from last week, but latency, of course, is an issue. And finally, the infrastructure of how you actually do that and what that is and how that all comes together. Now, controlling things remotely effectively means to control the infrastructure. So you need to, I'm going to fall over a stool there. You control the infrastructure remotely using something else. And obviously there has to be some kind of feedback loop coming back so that you've got some kind of understanding of what's happening. And of course, in the middle of this sort of circular movement, we have our old friend latency, and we have our old friend latency forwards and backwards, okay? So what do we do about that? So what I'm going to try and do is break these into individual parts, and we're going to see if we can answer some of those questions or resolve it a little. So I'm going to begin with talking to other devices, so talking to other hardware, for instance, be it virtualized or real hardware. And this brings me back to my favorite picture when I was an asset operator back in the day. And you can see here, actually, the KVM, as we call it, or keyboard, video and mouse, has been around a long time. The reason it's been around a long time, is because often hardware crates, the actual mainframes were in the racks downstairs somewhere, and the studios were always upstairs in the gallery. So you had to somehow get the control of the keyboard to the mainframe. And if you look at this picture, you can actually see here, there's actually a BNC cable here that goes right up to there. And that's how we moved the mouse commands to the mainframe. And then the response obviously would be the video here, which is coming back, which is the user interface for the graphics op. So we were already doing KVM, or keyboard, video and mouse, from way back. However, if I just wipe that away a second, things have changed a little bit with KVM. The technology's changed a little bit. So let me just throw this over here. Actually, I'll get rid of that. So when you think about it in a traditional sense, you're talking about a keyboard attached to a computer, a monitor showing you what's happening, and your mouse, okay? So in a traditional environment, that's kind of what you're looking at with keyboard, video, and mouse. So what we were just talking about there was actually moving the keyboard, moving the screen, and having them remotely talk to the mainframe from a different location in the same building. However, this has changed a little bit as well, because, for instance, if you were at home here, we would move the mouse and the keyboard and the screen to your house, okay? And then using IP technologies, we can actually send the keyboard and mouse data back to the hardware. Maybe that's at base, okay? So over public internet, we can send that back. And also we can send the video back over public internet as IP as well. So this allows us to control a hardware device that's on premise. Now, there's nothing wrong with this. There is a little bit of latency in there that has been greatly improved over the pandemic, but you do get a bit of that, when you're used to having a desktop sitting next to you, if you get any latency in the mouse, it's a little bit of a weird feeling. But it has improved, as I said. And if you need to actually talk to a physical piece of hardware in a building somewhere, and that's unavoidable in some cases, for instance, a vision mixer. So you could bring the vision mixer back home, the panel, and move its commands back to the actual mainframe in the studios, and therefore you'd be able to cut on the bus of the vision mixer. So you see a lot of that, audio desks in garages and stuff like that, and a lot of that is using this KVM technology. So that's the best way to solve how do I actually break the link between the two pieces of equipment up so that I can talk to it from somewhere else. So this is a very basic form of remote production. Okay, let's move on. So what about moving into a more optimal situation where you can actually start virtualizing things. So let's say I've got 3 users here, and we're going to use some virtual machines. Now, we talked about virtual machines, I think 2 episodes ago. So if you want more detail, just look on the YouTube channel, you can see that there. But I'll just roughly get into it. What happens here, and in very simplistic terms, okay, is here we have some infrastructure, some servers, and on top of that, there's some kind of orchestration layer here. And then on that orchestration layer, it's basically trying to split this server up into pieces, which will load as like an operating system. So let's say we have a Windows operating system here, and then on top of that, we have our machine number 1, okay? And we can repeat that using the OS there, and that's machine number 2, and here's machine number 3, and this is the OS here. So what we're doing is we're taking this hardware and we're slicing it up into virtualized machines. We're virtualizing the hardware. And that means that this user here, number 1, can log into this computer here and use it on their desktop remotely, okay? And the same thing applies for user 2. They can log into this one, and 3 can log into this one, okay? So effectively, we're dividing up the hardware here, and we're letting everybody access it. And the beauty here is that you can, machines 1, 2, and 3 can be all configured exactly the same. So everybody, for instance, could have the same editing software on there, or they could have the same NRCS software on there. It's no problem at all. The downsides of this, well, it's a little slower to boot up. It's a little more expensive because you have to keep hiring the OS underneath. And also, you know, if you've got a piece of software that you're running on the ground here on a computer and you want to put it here and it's not very good, it's still not going to be very good when you put it here. It's a bit of an excuse not to develop further. But in other cases, there are cases where people have developed VMs that are really good, that are using proper Unix shells. I'll move off that. Okay, so moving on to microservices. So this is really where we are from Next Edition standpoint. And the microservices is same piece of hardware here. But what we do is we have the OS sitting at the bottom of everything, and then we spin up services. So this would be, for instance, a transcode service, right? And this here, for instance, could be a prompter. And this one here could be, I don't know, like an NRCS, right? So 1, 2, and 3 containers. Now the difference here is that our users don't access a machine. This is virtualized software, not virtualized hardware. So each of the users are basically, a bit like when you think about web technologies, they're basically accessing websites effectively. But these services are elastic and scalable. So for instance, if computer number 1 and computer number 2 decide to transcode something, and there's not enough resource for this one, it will spin up another container, which we'll call 1B, and start doing that. So it's starting to be elastic and respond to what's coming in. So this is a much more agile way of working because we're using the resource much more wisely. But downsides with this is you have to write for this, okay? You can't just take something that you've already got and just throw it up as a microservice. You actually have to write microservices to work, which is something that, of course, we've done at Next. Now, that's talking about how we communicate to things and how that works. Now let's talk about infrastructure. So to do this, I'm going to use this sort of football analogy. I keep using this football analogy every week. I'll have to change it to rugby one day. So here we have a sports stadium, here we have a production team, and here we have someone at home waiting to watch a match. Now in a traditional scenario, there's 2 trucks in the car park here. And probably all of our staff there, maybe let's just say there's a studio in there, and the studio is here, and the studio is connected to these trucks, and the trucks send the signal up to the satellite or wherever, and then the satellite sends it home over there. The problem here is that we've got a lot of resource all tied up in one place. It's not very optimal to have, you know, all the graphics, the replay, everything is all tied up here. So it can only really cover this match, if you see what I mean, like that. So how can that be made more optimal? Let me just delete that. So what you could do, and in fact, what has been done for quite a time already, actually, interestingly enough, is the facility. You have a facility, fax. I like that. It's a good broadcast word, fax check. Everyone loves a good fax check. So here in the facility, we can have all the graphics, we can have the VT playback, we can have the hosts, etc., studios, anything like that. And then back here, we can take what's called a link, which is dark fiber. Okay, so this dark fiber link is basically a fiber cable that goes from the stadium directly to the facilities center. okay? There's nobody else on it. There's no internet traffic on it. It's totally reserved as a totally unique pipe between the facilities centre and the stadium. And this can be a long way away. You know, if you really want to do it that way, it can be a long way away. But what this allows us to do is to ship all the cameras and all the audio and everything and have a much smaller footprint here. So we don't have 2 trucks, probably have a small van. And just the camera operators, perhaps some sound operators as well. But generally speaking, most of the production and most of the resources in this place. And what that allows here is for this facility to do more than one game. This facility could do 6 or 7 games in a day because we're just taking different feeds from different stadiums around and able then to send those directly to the consumer. So this is a far more efficient way of doing it. So this is really the utopia of remote production. Now, how that works, if this is our facility here, so here's our facility, we have all the cameras on site, right? So our facility has this dark fibre pipe here. And the cameras these days are using something called bidirectional fibre, which means the cameras actually, not only can they send a signal back, they can actually receive a signal back into them. And what that gives you the ability to do is to rack the cameras. You can change the apertures or you can colour correct on those. And it's called racking. But that can now be done here in the facility as well. We don't have to put those racking people in the truck anymore. So these bidirectional cables we can actually bring in here. So you can imagine all of our cameras as individual ISO feeds coming back across this dark fibre straight in. And you can take your dolly cameras. There's a drone camera here, a couple of locked off cameras. We've also got a crane camera here, and because it's fun, I'll just change the colour. All our audio as well can come down here. Different audio, and of course our commentators, they could be either in a completely different location, or they could be on site, or they could be in the studio. Either way, it doesn't really matter. They can take their audio in, and we're bringing all this in. And here, bandwidth doesn't matter because we have a big pipe, gigabits of bandwidth. So we don't have any of that problem with the bandwidth issue. So it's a really, really optimal way to get it done. It works really well. The downside, this is really expensive. Okay, so this is top tier sports reserved for that because it's just way out of reach of a smaller broadcaster. It's an extremely expensive way to do anything. Dark fibre is very expensive. So how can we do this kind of thing without using dark fibre is the question. So what I've got is a bit of a case study actually. We did something with Broadcast Solutions and this is a drawing, I know, but showing drawings is very complicated. We had to do a complicated drawing at least once. But my friend at Broadcast Solutions, Malcolm Robinson, drew this up for me. It's a description of how we put together AFC Wimbledon's live return to plough lane game. And we wanted to try it out quite early in the pandemic to see how it would work. And I'm just going to change my colour to green here. And let me just explain what you see here. So this square here is effectively, this is Next HQ. So that's actually where I'm standing right now. And this is a very traditional setup. There's a router here, okay? There's a vision mixer here. There's an audio mixer here, right? Nothing out of the ordinary, nothing unbelievable there. In the middle, of course, there's Next. So here's our microservices. Okay, so all of our microservices are running for the VT playouts and the graphics coming, HTML graphics coming, etc. And the Next server's there dealing with all the automation of the studio components, for instance. But it's a fairly standard broadcast setup here. The difference here is these decoders on this side, which is interesting. Okay, because he says, this is the public internet here. So this is just where everybody is. Okay, and the gap between here and in Sweden and in London where the game was is here. So we're calling this remote locations. So let's start, I'm going to start with location number 2 here. And what's going on in location number 2 here is that this is where the cameras were, and we used a mobile viewpoint Sports IQ producer, which is an AI camera that tracked the ball. And we had some other, I think, Drinchik cameras going into Barracuda encoders, and a mobile viewpoint came with its own encoder. And we send these streams over public internet over SRT. So we're coming, the mobile viewpoint's coming, and the Barracuda's sending over the SRT. 8 sources in total. And also audio embedding, and well, it can get very complicated. However, here is me. So this location number 1, actually was me at my house, and I was 45 kilometers away from here. So I was 45 kilometers away from here. This was thousands of miles away from here, shifting all the cameras and audio from there. We also had a talkback system going in and some return video. And all of this allowed us even to take fans' WhatsApp videos and put them in live. So we were taking social media content and actually dropping it live into the show as well. And all of this because the director here, me the director, I could control Next and all the microservices to control all of the things in the studio, even though I'm 45 kilometers away and the camera's SRT in this way. So it's a little complex, but I think you get the idea that you don't necessarily have to use dark fiber. There is some latency in there, but it's actually quite manageable, and we actually managed to do quite a good job. I think we got about 30,000 viewers in the end, so it's quite interesting. Moving from physical hardware, so there I'm talking more about physical infrastructure, to cloud-based infrastructure. I think I've talked about this a bit before. I'm going to use Nextcloud as an example, but there are lots of vendors out there doing great things in this area. There's some really interesting stuff going on. It's very exciting. The problem with cloud is egress, right? So if you have to download something, say, so that you want to put it as an HDSDI feed, this is quite expensive, getting it back down again. So the best thing to do is to try to avoid actually bringing it down and keep it in the cloud. So you could take SRT, you could take NDI, you could take NDI over SRT if you want. You could take whatever streams you can get out the cameras, RTMP even, and you push that into the cloud, and then in the cloud you can remote cut it. So you can remote cut those feeds, and then so long as you don't need to go back to sort of a baseband situation, if you're staying as IP, you can put it out in different flavors even, and you can multi-stream out in different flavors if you like. So there's a lot of advantages around that. And another advantage there as well is the ability to take in feeds from other places. So you could take in, I think I've used this in an earlier presentation I did, but we could take in French, Spanish, German, and English commentary from other places and bring that into the cloud to meet the pictures and also enter different graphics information, and then we can push out localized, personalized video from the cloud. And that flexibility that's allowed there in the cloud is very exciting and moving in interesting ways. So we will see how that develops moving forward. Just to finish off, this is something that it's not a bugbear of mine, but it's just one of those things I come across and I always think it's interesting, is people tend to think that remote connectivity is strictly limited to cloud systems. Like you can only access things if you're talking to a cloud system. That's not strictly true, because this could be, for instance, let me argue here, this could be an on-prem solution of a hardware, and this could very simply just be keyboard, video, and mouse, and you're still operating it remotely, no problem at all. It could equally be, a microservice or a virtual machine running in the cloud, and it's the same. Or it could be a hybrid of both. You could have a little bit up in here in the cloud, say a couple of containers up there that are talking to this one, But to the user, to all intents and purposes, the experience is exactly the same. So connectivity isn't limited strictly to the cloud. You can access this stuff, if it's on-prem over a VPN, for instance, or over public internet. Right, so is it going to change everything? Well, of course it's going to change everything. It's a really interesting area, remote production. There are a lot of people doing a lot of cool things. There's been a lot of it around the Olympics, for instance, which was really, really interesting. I'm just going to see if anybody has any questions. Doesn't look like it, as always. Any more questions, people? So hopefully see you next week for Whiteboard Wednesday. I think we're doing broadcast and IT next week, so hope to see you then.